and tell me the problems that you want me to solve. 157. Okay, so we have 157. Okay, anything else?
I don't understand what to do with problem 150.
With which problem?
150.
150. Okay, I'm going to write it down and then we'll worry about things. Okay, what is it that you want me to do? 150. Anything else? That's it. Excellent. That's all that is.
Problem with problem
149. Okay. 149. Okay. Anything else before we start? Have you done 153 होगी सबसे? वन 154. फिर आप क्यों नहीं पूछ रहे? क्या ट्राई नहीं किया हुआ? Okay, I mean just saying कि this is your chance to ask questions and if you haven't, अगर आप लोगों ने खैर that's really your choice जो भी आपने पूछना. जी कोई और सवाल हैं जो किसी ने पूछते हैं? All set? All set? All set, I said. Yeah. Okay, so let's start out with these problems and see what we can do with them. So let's try 149 first. So before we try 149, I want you to talk about 148 first. So can somebody help me understand what problem 148 is? So 148 leads to 149. So let's understand 148 first. Taken? So let's look at 148 first. That's what we want to do. Okay, 149 se pehle let's look at 148. So what's the sort of the reason for doing 148? So the question is, what's the maximum possible number of roots for a polynomial having degree 5? Okay, and sorry, this is my mistake. This is sorry, not 148. I made a mistake. It's 147. So let's look at 147. Here is 147. So I'm going to go back to 147. So does everybody understand 147? The numbers 1 and 2 are roots of a polynomial p. Prove that p is divisible by x1, x minus 1 and x minus 2. So does everybody understand this problem? Sorry, I can't really. I think there's a lot of noise coming from outside. G.
So there is the last statement. X said that so q is divisible by x minus 2. That is q equals x minus 2.
Right.
So times remainder here. Why did we?
Okay. So can somebody answer Samin's question? So Samin's question is, कि in the last line of the solution, it says that q is divisible by x minus 2, that is q is equal to x minus 2 multiplied by r for some polynomial r. So why is that your question?
So is r the quotient?
R will become the quotient of the entire thing if you divide by x minus 1 and x minus 2. Lekin, why is that true? So let me ask you this question. So if a polynomial is divisible by x minus 2, why is it equal to, I'm just asking a question. So if a polynomial, let's say p नहीं करते, उसके इस केस में क्या है, p है, q है. So if I say q is divisible by x minus 2, so why can we say q is equal to x minus 2 into r for some polynomial r, for some polynomial r, for some polynomial r. So why is that true? Ji. That is true, R is a quotient, but why is it कि if I say Q is divisible by x minus 2, इसका any what, can you just go through the argument? It's a fairly simple argument, but you still have to go through it. क्योंकि divisibility of polynomials का हमें मतलब पता है कि क्या मतलब होता है, right? So what's the division algorithm for polynomials?
It's the same as the.
But you use the what's the equivalent, वहाँ पे हम numbers को use कर रहे होते हैं, यहाँ पे हम polynomials के लिए क्या use करते हैं? What's the equivalent of numbers that we use? We use the degree of the polynomial as the equivalent of numbers, right? So if you divide the polynomials, you're always trying to match the highest degree. So if you try to divide, I don't know, let's try to divide x cubed minus 1 by, let's say, x plus 1, so you try to match, let's say, by 7x even, right? So what do? You try to match the degree. You say it is 1 over 7x squared, and you will get x cubed here, and you will get plus 1 over 7x squared. Then you will subtract off, and you will get minus 1 over 7x squared here, and then you will multiply it by minus what? 1 over 49 x, right? And so on and so forth. And you will get minus 1 over 7x squared, and you will continue this division. So, and इस division को हमने justify किस तरह किया था? किसी को याद है? How did we justify this division? Because we showed that this is all legal by, if you look at जो है the time that he spends, if you look at the work that he's doing on page maybe 63 and 64. So he's showing you on pages 63 and 64 that these are all legal operations. Okay? अगर आपने जब division algorithm सीखा था तो आपको उसूली तौर पे somebody should have proved to you the correctness of the division algorithm. Why are all these operations legal? जो हम long division algorithm करते हैं, that's not obvious, right? I mean, if I am doing 203 divided by 7, why is it that I write a 0 here and I say, oh, 2 7s are 14 and 63 and 9, and the answer is 9 7s are 63 or something like that, right? So why can I do that? That's not division. Division ye tha, what was division? Division was essentially the reverse of multiplication, meaning if I could divide 18 chalks among 3 children, then each one of them will get 6 because 3 6s are 18. That was what division was. तो ये कहाँ से आ गया? ये तो एक अजीब सी चीज़ मैंने की है, इसका उससे कोई ताल्लुक नहीं है. There is nothing, this division has nothing to do with my story that I just told you, right? So there's a gap Do you understand? There's a gap, right? Because why is 18 divided by 3 equal to 6? Because 6 3s are 18. That's all that you know about division. इसके अलावा आपको division के बारे में कुछ नहीं पता. Do you understand what do you know about division? Yeah? So ये इसका तो कोई ताल्लुक नहीं है उस स्टोरी से जो भी मैं आपको बता रहा हूँ. ये क्या अजीब सा तरीका है कि अगर ना कर सको एक अंदर लिख दो एक बाहर लिख दो, फिर यूँ करो, अगर डिवाइड नहीं होता तो 0 डाल दो, फिर then you consider this to be 20 and then 2 7s are 14. What is this? Looks like nonsense, right? So there's a proof that is required to go from this story, which is 18 divided by 3 is 6, means 6 3s are 18. So यहाँ तक जाने में there's a gap, and the gap is covered by a proof. यहाँ पर there is also a gap. What is allowing us to do this silliness? And what is allowing us to do this silliness is the explanation that Gelfand has on pages essentially 63, जब वो आपको दिखा रहा है कि जो हम काम कर रहे हैं, it is essentially working with fractions, and जो सारा उसने explanation दी हुई वहाँ पर है. Okay, so now I was asking you, why can you, so when you do this division, so the division algorithm, so this is the story, right? Why is the division algorithm for polynomials okay? What is the legality? क्या proof क्या है हमारे पास for the legality of the division algorithm?
So for the long division algorithm.
Yeah, for polynomials. I'm not interested right now in whole numbers क्योंकि मैंने वो पढ़ाया नहीं है इसलिए मैं आपसे पूछ नहीं रहा, लेकिन whole numbers का तो हमने polynomials से तो किया था in class. So what is it? अभी मैंने आपको बताया है. No. This is the work that Gelfand is doing on page 63. So you have to understand the work that is done on page 63. जिस तरह अगर आप देखें उसका जो part है, take for example, अगर आप example देखें, converting the improper fraction x4 over x minus 2, he does it एक तरीका है which is the long division algorithm. दूसरा तरीका है he is working with fractions directly, right? And he is showing you that working with fractions directly is exactly the same as working with the long division algorithm. So that's a justification for the long division algorithm for polynomials. Okay? ये बात समझ आ रही है आपको? So the story is this. This is the story. The story is कि long division algorithm for polynomials justified by so now we believe by work done on page 63 maybe. So the work done on page 63 justifies that why does the long division algorithm work. So once you understand why the long division algorithm works, then you know that for any polynomial p, if you divide by any divisor, so you can have a divisor like, अगर आप ये कर रहे हो, this implies take any polynomial, I'll take the polynomial q. If you divide by any linear polynomial, right, you will get a quotient. So the quotient is maybe PQRS. So maybe I'll call it S of x, या maybe इसको मैं R ही कह देता हूँ जो यहाँ पे लिखा हुआ है, R of x plus a remainder, right? What is the degree of the remainder by the long division algorithm?
1 less than the degree of the divisor.
Which is, so what's the degree of the divisor in this case? 1. So what's the 1 less than 1? 0. So what's the degree 0 polynomial?
1.
A constant. So that means this has to be a constant c, right? That's what it has to be. That's what the long division algorithm tells you. But now, if something divides, if something is divisible by by x minus 2, that means that the remainder is equal to 0, right? There is no remainder. So this means that this constant is equal to 0. There is no remainder over here. So in general, whenever something is divisible, तो आप ये कहते हैं कि the degree of the remainder is going to be less than the degree of the divisor, and in this case चूँकि the divisor was going to be जो भी है, the divisor was a linear polynomial, इसलिए this was a constant and the constant was equal to 0 in this case. So yeah, so इसकी justification is just a long division algorithm. Okay, so अब हमारा सवाल क्या था, हम 149 को हम समझ रहे थे कि हमने ये देखा जो the question 147. So 147 का मंतिक क्या था, उसका मंतिक ये था कि अगर हम इसको लेके चलें very simply, which would be कि so we have P is divisible by I think x minus 1 and x minus 2, right? And we have to prove P is divisible by the product, right? कोई इस तरह की चीज़ है, is that right या नहीं? Right. So yeah. So if 1 and 2 are roots of the polynomial, that's exactly what it means. It is divisible by x minus 1 and x minus 2. So now we have to prove it's divisible by the product. And I gave you an example too in class. What was the example? If you were awake, you would have remembered that example.
Said that it's if you think about it.
Numbers. मैंने numbers का एक example दिया था. Yeah.
Said that if that 12 is can be divisible by 6 and 4.
Right.
But you can divide 12 by 6 and 4.
Exactly, right. So the example was it's not obvious. If you think, oh, this is obvious. So for example, if you take 12, you can divide it by 6 and that's equal to 2. And you can take 12 and you can divide it by 4 and you can get 3. But certainly in the whole numbers, 12 divided by 24 is not a whole number. You can't take the product of any two divisors and say, okay, oh, the product ke liye bhi that is true. And then I said, okay, it's true for prime numbers. In the realm of whole numbers, it is true from prime numbers. So if you take a number and it is divisible by one prime p1, and you take the same number, it is divisible by p2, another prime, then it is also divisible by the product of primes. That's a remarkable thing about prime numbers. So what that's showing is, कि अगर I was trying to show you the equivalence, कि x minus 1 and x minus 2 are playing the role which is equivalent to prime numbers. Okay, that's what I was trying to show you. Okay, it's a kind of a different thing. जो अभी आपको नहीं पता what do I mean by prime numbers in this domain of polynomials. अभी आपको नहीं पता, हमने define नहीं किया, ना हम करेंगे. This is much more advanced algebra जो आप college में जाके करते हैं if you are interested in that kind of stuff. So, लेकिन what I'm trying to convince you is it's not a very obvious thing. If something is divisible by something and then that same thing is divisible by another thing, then it should be divisible by the product. That's not an obvious answer. So we have to make an argument, and the argument was, जो उसने argument दिया था वो ये था कि p is divisible by x minus 1, so that means p is equal to x minus 1 into some quotient q of x, right? So this is what I know about p of x. Is this clear? Is this clear to you? Okay. Now we know that p is also divisible by x minus 2. So what does it mean? It means that 2 is a root of the polynomial p. So I can put p of 2. So p of 2 I know has to be equal to 0. Why? Because 2 is a root of p. Agree? Root of p, right? So that, but p of 2 is also equal to 2 minus 1, ये हमने पहले किया था, q of 2, right? So this turns out to be equal to 0 is equal to 2 minus 1 is 1. So this is saying q of 2. So what does it mean? That 2 is a root of q. So 2 is a root of q. So which implies, i.e., 2 is a root of q. 2 is root of q, which means that another way of stating the same thing is q of x is equal to, is divisible by 2, so this is equal to this, right? Agreed? Some other polynomial, because anything that is divisible, 2 is a root of q, means q is divisible by x minus 2, which means q of x is equal to this thing, right? And now if you put together star and double star, so what you find out is that p of x is equal to x minus 1 into x minus 2 into r of x. So that shows that p of x is divisible by x minus 1 and x minus 2. Is this clear? That was the argument of 147. ठीक है? Yeah? The divisibility is because if you divide by x minus 1 and x minus 2, you will get r of x as the quotient. So now let's move to 149, which was actually the question that's been asked, which is now I want to check. So let's move to 149. I want to check whether q is divisible by, so p. So now let's talk about 149. So 149 says, how would you check whether a given polynomial, so let's take p is a polynomial. So the question is p of x divisible by x square minus 1? So now can somebody help me answer this question? Right, that's the question. So we are given p and we want to find out whether p is divisible by x square minus 1. So क्या करें? Okay, इसको factorize कर सकते हैं हमें, yeah, I mean, so probably I would not suggest कि, yeah, you can talk about the root or, so this is just equal to this, right? So this is that. Okay, so ये तो मुझे पता है. So now what? कर लिया.
So what if we check if minus 1 and plus 1 are roots of?
Okay, अगर कर लिया तो फिर क्या होगा? In fact, that is the answer, but होगा क्या? कर लिया हमने check. How does checking कि these two are roots confirm कि it is divisible by x minus 1 and x minus 2? That's the question. So note, what does it mean for p to be divisible by x minus 1 and x minus, so x square minus 1? So p being divisible, p divisible by x square minus 1 का मतलब क्या है? मतलब ये है कि p of x is equal to x square minus 1 into some q of x. Agreed? That's what it means for, इसका मतलब ये है. This is what it means. Right? Do you understand? Divisibility का मतलब है there is no remainder, right? If something is divisible by something, that means there is no remainder. So that's what it means, right? So that means that this is equal to x minus 1 into x plus 1, because I know that this is true. So now what this is saying is what it shows is कि if p is divisible by x square minus 1, then p is equal to x minus 1 multiplied by x plus 1 into q of x. What that means is that 1 and minus 1 are roots of p, right? Agreed? Because when you put in 1 you get a 0, when you put in minus 1 you get a 0, so that means 1 and minus 1 are roots of p. So, if p is divisible by x square minus 1, then minus 1 and 1 are roots of p. And if minus 1 and 1 are roots of p, then we know through that argument, then p can be written in this form, right? So, it is an if and only if statement, which means that p being able to is p divisible by x square minus 1 is exactly the same question as are 1 and minus 1 the roots of p, and you can just check. इसके बारे में कोई सवाल, कोई चीज़ अनक्लियर हो?
सर आपने मुझे कहा है कि इस क्वेश्चन से रिलेटेड है.
Yeah. Okay. So let me try to explain. Yeah, sure. Let me try to explain to you. मैं ये कह रहा हूँ. So hopefully आपको ये याद रहेगा सवाल कि I have to erase this board. Okay. So now the question was, is p divisible by x square minus 1? मैं ये कह रहा हूँ. So my claim is divisibility by x square minus 1 is equal to, यानी कि if and only if statement है कि if you are divisible by x square minus 1, then you will be divisible by x minus 1 and x plus 1, and if you are divisible by x minus 1 and x plus 1, then you will be divisible by x square, is the same as divisibility by x equal to 1 and x equal to minus 1. So that's the same statement. मैं ये claim कर रहा हूँ. अभी मैंने prove नहीं किया, मैं ये claim कर रहा हूँ. How do I prove it? Well, the way I prove it is, यहाँ पे divisibility by x, मैं अभी I'm moving in this direction. पहले मैं ये करने लगा हूँ. Okay, this direction is I'm going to assume that the polynomial p is divisible by x square minus 1. The polynomial p is divisible by x square minus 1. That's my assumption. Okay, and I'm going to show you that the polynomial p is also divisible by x minus 1 and x plus 1. पहला मेरा ये काम है. Is this clear? क्या मैं करने जा रहा हूँ? Okay, now see how I do it. P is divisible by x square minus 1. Okay, that means p can be written as a product of these polynomials. Agreed? Which means since x square minus 1 is equal to x minus 1 and x plus 1, p can be written as a product of these polynomials. Agreed? Which means p is divisible by x minus 1. It is also divisible by x plus 1. Agreed? यहाँ तक ठीक है? So I've shown you that divisibility by x square minus 1 is the same as divisibility by x minus 1 and x. Oh, sorry. Maybe that is what was bothering you. Okay. Is that clear? Sorry. ठीक है? Yeah? Now, so I've shown you this side of the arrow. कि if you assume divisibility by x square minus 1, you can show divisibility by x minus 1 and x plus 1. Both have to be true. Now for the flip side, अब मैं वापस जाना चाहता हूँ. So ये हमारी assumption होती है in general. So this is what the arrow means, right? And this is your conclusion. So अभी मैंने assume किया ये side और prove किए ये side. अब मैं ये side assume करूँगा और वो side prove करूँगा. So then it becomes a statement कि both things are either going to be true at the same time or false at the same time. So they're the same statement. So now I'm going to assume divisibility by x minus 1 and x plus 1. Okay? So now remember, अभी हमने जो 147 किया था, इसके लिए हमें 147 चाहिए. Because अभी हमने जो 147 किया था, उसमें हमने कहा था कि 1 and 2 या minus 1 and minus 2 are roots of a polynomial. Then actually it is divisible by the product. तो अब यहाँ पे हमें पता है कि it is individually divisible by x minus 1 and x plus 1 and we have to prove it is divisible by the product. Okay? So uske question just phrased in a different way, and that is very easy to check. You just put in 1 and minus 1 and if it is turned out to be 0 then it works out. Okay? Is this clear? Yeah? Okay? So now let's move to 150. 150 आपने पूछा था? Is that right? Okay, good. So let's look at 150. Anything? ये 149 now going away, and now we're going to talk about. So again, I'll urge you very strongly to read Gelfand carefully. Don't just आपको आदत पड़ी हुई है worked examples को वैसे ही skim through करने की. Those were your regular books. जो not very smart people wrote those books. So Gelfand is very, very smart. So everything he writes down actually has serious meaning. So read the books carefully. Everything has a reason for it being there. You should understand that when you're reading somebody smart's book, you have to really worry about what they're trying to say. Okay. So now 150 hai. So we want to figure out x to the n minus 1. This is 150. And we want to figure out, what do you want to figure out? कि 150 के बारे में when is, for which n is x to the n minus 1 divisible by x square minus 1. For which n? Okay, so help me. So can somebody help me do this question? Sorry? Actually, one value से बात. Okay, so the trivial answer is when n is equal to 2, it is certainly divisible by x square minus 1 is divisible by x square minus 1. That's true. But that's not probably what Gelfand is asking. So if you gave this answer, this would be okay for the Singapore math books that you were using, but for Gelfand it would be inappropriate. Okay, it would be making fun of the wise man. So that's not appropriate. Okay, so we have to give a decent answer. So what would be a decent answer? And how would you arrive at something like this? अभी हमने पिछला सवाल किया जो आपने पूछा था 149 आपने पूछा था. So divisibility by x square minus 1. How do you take divisibility by x square minus 1? When? What are the roots? 1 and minus 1 are the roots of the polynomial. That's the same thing. Can you check whether 1 and minus 1 are the roots of this polynomial? As simple as that. That's the answer. So you can use 149 to answer this question. So this question was answered by 149. So you can figure out for which values of n are 1 and minus 1 the roots of this polynomial. Okay? Good. Last question. Oh, we are done. I like it. I like not having to work. It's very good.
We can usually get 10 students, so there are 10 problems to do.
My dear friend, I really feel कि अभी आप लोगों ने काम नहीं किया हुआ. Otherwise you would have had 10 problems. That's my feeling. Individually. अगर आपने काम किया होता ना तो आपके बहुत ज़्यादा सवाल होते. आप लोगों ने उतना काम नहीं किया हुआ जितना आपको करना चाहिए था. But I mean, you have to make your choices in life. Okay, 157. Okay, prove that for any polynomial of degree 2, all second differences are equal. We did this problem in, हम करके हटे हैं, right? In one of the online lectures that I uploaded, I think we did this problem quite recently actually. Yeah. So what was it that you didn't understand about this, your problem? How about you do it right now? Do you have a copy? Yes. Do it in front of me. I'm surprised कि ये नहीं हो रहा. सारे लोग just do it right now. Here's a polynomial. So p of x is equal to ax squared plus bx plus c. So now do it. Kare and calculate second differences and show me what do you get. Because I do not believe, so you have to see how you did 156, and the way you did 156, you can exactly do 157, monkey see, monkey do, you just copy 156 and you get your answer out. Okay, so how about you do it quickly? Time हमारे पास शायद है. We have time. Okay, we have 10 minutes. Surely we will be able to answer this question very quickly. अब तक आपको गेलफंड इतनी बार पढ़ जानी चाहिए कि यू शुडंट हैव टू रीड इट अगेन. दैट्स द लेवल दैट यू नीड टू रीड इट. 5-7 बार पढ़ना गेलफंड कोई अजब बात नहीं होनी चाहिए. शुड बी रीडिंग इट एटलीस्ट 4 to 6 times पढ़ना until you really understand what he is saying is not the worst thing in the world to do. Actually is highly recommended. Start working, Mr. Daniel. This is not the time to think. There is no thinking required. How are you starting?
Sir, remember I copied the answer you wrote in the Google Classroom.
Now, how about you start out? Have you started?
No.
How about you start?
Okay.
I want actually people to be write down p of x and start working out what the differences are. इसका difference बेटा सही था. So what you have to do is look at the difference between the two. The difference between the 4a और a के बीच में कितना फ़र्क होगा? Yeah, making mistakes. So do it carefully. Do it carefully. Do it carefully. Otherwise, you will make a mistake and the answer will not turn out to be correct. So the calculation should be done carefully. We have enough time, don't worry. Okay, we are going to try 3 values n plus 1 and n plus 2. So p of n is equal to a n squared plus b n plus c. P of n plus 1 is equal to a n plus 1 whole squared plus b n plus 1 plus c. उसको अगर आप expand करें तो this is what you get. Now p of n plus 2 will be equal to a multiplied by n plus 2 whole squared plus b n plus 2 plus c, which turns out to be equal to a n squared plus, now I'm going to get a 4n from here and I'm going to get a 4an. So I'm going to get a 4an plus bn. Then I'm going to get a 4a from here, 2b from here and a c from here. So I'm going to get a 4a plus 2b plus c. Okay, hopefully the math is correct. And now the algebra is correct. So now let's look at differences. So if I look at differences, so I'm looking at Pn plus 1 minus Pn, and what's that equal to? Well, that's equal to beta यहाँ से 2 times 2, oh 8an, absolutely. I'm 2n से नहीं 4an sorry, yeah 4an sorry, so it's 2n, और 2n को जब मैं डबल करूँगा तो I'll get 4n and 4n multiplied by a is 4an, it's 4an. Okay, yeah, okay. So now Pn plus 1 minus Pn, if you look at the differences, this gets killed. I get a 2an, so 2an and plus a plus b, and that's it. That's what I get. And when I look at p of n plus 2 minus p of n plus 1, I again get the an squared gets cancelled. I'm going to get 4an minus 2an, which is going to be 2an. 2an, the bn's will cancel again, right? And I'm going to get a 3a plus b, right? Plus 3a plus b. And now, if I look at, let's call this equation 1, because I need to care about the differences of differences. So now these are differences, and I care about differences of differences. So I'm going to calculate 2 minus 1, and that's going to be the difference between the two. So this is just going to be equal to 2a, and that's the answer, right? Okay.
Don't you have to do it for Pn minus 1 as well?
No, because I just care about differences of differences, right? So I need to calculate. I got the difference between Pn and Pn plus 1. N is any whole number, right? So I got the differences between these two, and then I got the differences between these two, and the differences between these two as a difference of a difference, right? So अगर मैं n minus 1 से शुरू करता, तो it could have been n minus 1, n and n plus 1. That would have been fine. क्योंकि but n is any whole number, so it doesn't matter.
So sir, हम Pn plus 1 और Pn plus 2 की जगह Pn minus 1.
You could have chosen this, so it was perfectly fine. You could have chosen Pn minus 1. You needed 3 numbers, 3 continuous numbers, right? So यहाँ पे your n, the constraint is that n, there's no constraint, sorry, because these are all integers, so it's all immaterial. अगर मैं यहाँ पे n को 2 डालूँ, आप यहाँ n को 3 डालेंगे, you'll get the same answer. So it's the same thing. So you could use any 3 continuous numbers and you would get the same answer. Okay? All good? Okay. So I guess अगर आपके कोई और questions नहीं है, तो I don't have anything else to talk about. Except जो मैं बार बार आपको advice देता हूँ कि spend time, read carefully, read multiple times, try a lot. इसके बगैर कोई इलाज नहीं है. Anything else? या do we stop? जी. किसकी? Oh, counting. Sure. That was very simply this idea. I don't know whether we have a time to actually go through it. You'll have to probably. Subsets. Yeah. So let's look at this. So here's a set. So let's take a simple example. Here's a set which comprises of 3 letters A, B, C, right? Let's look at which is called actually the power set of S. So this is the set of all subsets of S, okay? All subsets of S. कौन से हैं? So this is the empty set, right? The set A, the set. So this is the set of all subsets, okay? The set B, C. Then you will have A, let me go down, go to space only. So then you will have the set AB, you will have the set, maybe I'll do it here, sorry, AB, and then you will have the set AC, and then you will have the, I should have done it in a different way. Okay, it doesn't matter, okay, that's fine. And then you will have the set BC, and then you will have the set A, B, C. Empty set, the set which does not contain a set is by convention always a subset of every set. It makes things easy because when you, there are a lot, so why do you have this convention? There's another story here, किसी और दिन मुझसे पूछिएगा, why is it true, okay? But the reason is again convenience, exactly for the same reason as 1 is not a prime number because it destroys a beautiful theorem. इसी तरह the empty set being a subset of every set makes our theorems very nice and beautiful. So we like nice and beautiful things, we don't like ugly things, and that's why we make this convention that the empty set is a subset of every set, okay? So now I can relate strings. So this is what I'm going to do. So let me do it here. So here's the subset phi, and I'm going to relate it to the string this, okay? Here's the set A, and I'm going to relate it to, and here's the set B, and I'm going to relate it to, I should have started from the left, I think. Yeah, it doesn't matter. Here's the set C, and I'm going to relate it to, okay, and here's the set AB, and I'm going to relate it to, and here's the set AC, I'm going to relate it to, and so on and so forth. Do you understand? This represents whether A is present, this represents whether B is present, and this represents whether C is present. So you see there is a one-to-one correspondence, meaning कि और ये मैं आगे भी कर सकता हूँ सबके साथ. Do you buy it कि नीचे भी हो जाएगा, BC के साथ होगा और ABC के साथ भी हो जाएगा. So I'll be able to do all of these things, right? So what does it mean? What that means is कि there's a one-to-one correspondence between bit strings and subsets, right? Is this clear? So counting bit strings is the same as counting subsets, right? So what does it mean? So how many bit strings are there? Well, remember there are two choices for the first one, right? The first one could either be a 0 or it could be a 1. Right? How many bit strings बना रहे हैं? Bit strings of length 3. So the first one could be a 0 or a 1. Now the second one could also be a 0 or a 1. And the third one could also be a 0 or a 1, a 0 or a 1, a 0 or a 1, a 0 or a 1. So now note, every time we are branching off into two branches. So this is like a giant with two arms. Each arm has two hands and each hand has two fingers, right? So har bar 2 times 2 times 2, but so how many fingers are there? Well, the number of fingers, so this was the giant with two arms, and the arms had two hands each and the hands had two fingers each. Well, how many fingers are there? Well, it's twice the number of hands. How many hands are there? Well, those are actually, so the fingers are equal to twice the number of hands. The number of hands are twice the number of arms. The number of arms is twice the number of giants. And the giant is 1, so it's just this, which is 2 into 2 into 2, which is 8. Is this clear? So that would be twice the number of elements in the string. Is this clear?